This is the starting point for everything we build, a raw collection of polygons suspended in a digital coordinate system. 3D animation relies on a sequence of specific engineering stages. Every movement on screen is the result of a precise, multi-departmental production pipeline. To see how that works, we need a controlled environment, one equipped with overhead lighting grids and industrial sound blankets. To reach a final performance, this digital model must move through several distinct production layers, beginning with its internal structure and ending with a high-intensity data render. We begin in the writer's room. Before any software is opened, the team must finalize the script. Modern studios use large language models to rapidly iterate on plot developments, dialogue formatting, and initial idea generation. An animation script uses a 2-column format to map dialogue alongside visual instructions, specifying scene durations and character actions. From there, the team moves into layout. This is where we test camera compositions and character interactions in a 3D environment to see if the timing works. Addressing these narrative choices early prevents technical waste during the more expensive phases of production. In the rigging bay, we build the character's internal logic. A 3D model requires an internal skeleton to allow the mesh to deform. This complex network of joints and control points is known as the rig. It functions as the interface an animator uses to manipulate the geometry. The next step is skinning, the mathematical binding of that 3D mesh to the skeletal structure. To ensure the model bends correctly, we use weight painting. This process assigns a specific level of influence to each joint over individual vertices. If the vertices aren't merged or the influences aren't mirrored accurately, the digital surface will tear, creating visible holes in the character during motion. Reading provides the anatomical engineering required for every movement that follows. Once the rig is stable, animators begin blocking. They set the primary poses and silhouettes to establish the physical positioning and timing of the shot. During splining, the software calculates the frames between those poses to create smooth, continuous motion. We then add overlapping action, ensuring that different body parts move at offset speeds to simulate weight and inertia. Finally, we layer in microfacial movements and lip syncing to keep the character active in every frame. This is the application of physics to a digital object, creating a sequence of motion that viewers perceive as a living performance. In the rendering bay, we add atmospheric layers. Environmental lighting is used to create depth, cast shadows, and set the mood. This is technically demanding. GPU engines like Redshift calculate the behavior of light and texture data across thousands of individual frames. In compositing, separate video and audio layers are unified. This is where we add post-production effects like camera shake or color grading. This final output shows the impact of that data. The raw mathematical viewport is now a cohesive image with accurate textures and lighting. Post-production is where these individual technical departments merge into a single cinematic experience. This is the final form, fully rendered, textured, and moving fluidly. We moved from a blank script to a weight-painted rig and a final splined performance. The 3D pipeline is a marriage of creative storytelling and precise mechanical engineering. Every stage we explored is a specialized department. If you want to build digital worlds, these are the disciplines you need to master.